Hello folks, Professor Mosier here, and this week I'm going to share a little bit of information with you about the processing programming language. Processing is a very high-level programming language, meaning that you can do a lot of things with it very quickly, and it takes care of a lot of the details for you. Processing was developed by Ben Fry and Casey Reese a few years ago at MIT, and it was designed to be very good at image processing, animation, and data visualization. So the other day, one of my friends sent me this picture of all these Donald Trump heads. And I really like this image, and I think that it would be a great way to sort of demonstrate the capabilities of processing, because we can make something very similar to this with processing. Or we can write a program that will let us to draw whatever kind of Donald Trump head composition that we want to do. So, that way from now. If you don't have processing, it's free. It works on both Mac and Windows, and you can download it at the processing.org website, and by just going to their download link. And it may or may not be on the computers in the lab. If it's not, you can download it and install it to the desktop, not the applications folder, and it won't ask for an administrative password. Okay, so after you download it and open the program, you'll get this. This is their interactive development environment, or IDE. Very simple and straightforward. Up here in the large white space is where you type your code, and down here in the black space is where you'll see your serial prints, your errors, debugging, things like that. Now, very few buttons at the top. The play button will run the program that you've written so far. Stop will stop it from running. New lets you create a new sketch. They call processing documents sketches, not documents or files, because it's very sort of rooted in this kind of like fast, quick code snippet things. Similar to how an artist or designer would keep a sketchbook, you can keep your little sketches in processing. You can open one of your past sketches here, save sketch, or export the application as a standalone thing. And over here on the right hand side, you can select which language it's going to use as its base. I'm going to leave it at Java. Okay, so I like using processing because it is high level. It's pretty straightforward to understand, and that makes it a great way to learn the fundamentals of computer programming. And to demonstrate just how high level this is, I'm going to make a very simple sketch, kind of like a Hello World sketch, where I want it to just draw a line. So I'm going to tell it line, and I'm going to give it 2 points to draw this line. And processing uses pixels for almost all of its measurements. So this would be from pixel 10, 20, so these are XY points, so that's one XY point. And then the end point, let's say 60, 70. So 4 values separated by commas. I end my lines with a semicolon, and I'm just going to run that. And here we go. Here's my little sketch. And so it's done a lot of assumptions for us already. It's given us a size of the drawing that it's going to make, or the image that it's going to make from our code. It's decided on its own the background color for that window. It's this gray. It's not white or black. It's decided that the line is going to be black. These are all like defaults that we didn't have to tell processing to do. But we can change those things. So I could stop the program over here, or I could just close this window to stop it as well. So if I want to change the color of this line, I can add a color statement, and I want to do that before I actually draw the line. And to change the color, I use the stroke command, because a line just has a stroke. There's strokes in fills, much like there are in Photoshop. So lines have strokes. And I'm going to give this an RGB value. So let's make it a red line. So we'll do 255, 0, 0, and semicolon. Run that. There we go, red line. Great. Now, even more interesting perhaps with processing and how it can dynamically change its commands. If I give the stroke just one variable, 255, it's going to assume I want a grayscale, so it's going to give me a range from white to black. So this should give me a white line. Alright, so we will run this. And there we go, white line. What if we want to change the background color? Also fairly straightforward. We can say just background, and same thing, RGB. Let's make the background orange. So I'll do 255, maybe 120, 0, run that, and white line, orange background. Okay, maybe we want to change the size that we have to work with too. Fairly straightforward. We can say size, and we're going to give it pixels, width, and height. So we could say 300 by 200. And there we go. Bigger, slightly bigger drawing. And you'll notice our line is still in the same point there. So processing works in a kind of interesting way in terms of its coordinate grid. So our first point is x10, y20, which it's saying is there. So that means that x increases as we go to the right, but y increases as we go from the top to the bottom. Right, so it's a bit different from a traditional Cartesian grid. So once we've set the width and the height, we can use that information in our application. So for instance, let's say we wanted this line to start at the middle of our canvas. So I could do math when I'm writing the code and be like, okay, half of the x would be 150 and half of the y would be 100. That should be the middle. And we'll see. Yep, so going from the middle up this time. But that's a little problematic. It's not the best way to write code, because if I change the size of my canvas, it's no longer drawing from the center. And maybe it's really important that I draw from the center, right? So I can also use my width and the height as variables. So I could say width and height. But that's not going to give me the center, right? Because the width is 300, so that's going to give me the sort of lower right corner is going to be the starting point. But if I say width over 2 and height over 2, it will give me the center. It will give me that 150/200. So I can do math within my function calls here. And we'll take a look. Great. Center. And now if I change it back to 200 for the height, we'll stay in the center. Great. Okay. So up until now, we've been coding in static mode. So it's running each of these commands once, and then the program stops and doesn't do anything. If we want to make something that's interactive or responsive, right? Maybe I can click a button, or maybe it'll do something depending on the mouse location. I need to be constantly checking for what keys are pressed for where the mouse is. So I need to be looping this parts of my sketch over and over again as long as it's running. So I'm going to add two custom functions, and you will find these functions in almost any processing sketch that's running in what's called active mode, and that it's constantly looping. We need to do two things. One, we need to set some stuff as a setup. So these are things that will run once, right when the program starts, and then won't run again. And the syntax for this is I'm going to create a function. It's not going to return anything, so I'm going to say it's void. It's called setup. It has to be called setup. It's not going to take any arguments, so it's got nothing between its parentheses. And then I'm going to use curly braces that open and close to contain the stuff that's going to be in that setup function. And so this is where I would put all of these things. So I'm going to copy and paste those up here. And to keep myself sane, some good coding practices do indent the items each time you curly brace, so you know that these things are within the setup. Then my actual drawing are going to be in a different function, and they're going to be in a draw function. Same as setup. There's no argument returned when draw runs, so it's void. Takes no arguments, so it's got nothing between the parentheses, and we use the curly braces again. And so now it's going to keep drawing this line over and over and over again. When it gets to the bottom of the curly braces, it just goes back to the top, and it does that forever, as long as the program is running. If I run this, it should look very similar to the last thing I did. Yeah, great. So it's actually drawing this line over and over and over again, right on top of the previous one. I'm noticing a little sort of pixelation on that line, so I'm going to put in smooth function so that it draws everything smoothly. It'll take it a little bit longer to run though. Okay, so let's say we wanted to get interesting here. We could draw from the center of the screen. Let's say we wanted to draw to the mouse location. Very simple to do. Again, processing is very high level. I can say mouse X and mouse Y, and that's going to give me the X coordinate of the mouse and the Y coordinate of the mouse, as long as the mouse is within the drawing canvas. So we'll run that. And it always defaults to thinking that the mouse is in the top left, which is the 0, 0 point. And as soon as I bring my mouse in, it's going to start drawing lines to the mouse point. Now, it's going very slow on my computer because I'm doing video recording. So that's using up a lot of my processor speed. But we can see, we'll draw these lines around. And I could do this until the whole screen gets filled up with white lines. So what if I don't want that? What if I want it to just draw a line, so it looks like the end of my mouse is connected to the center, and that just moves around the screen without sort of doing this painting thing that it's doing. I can do that as well. First, I'm going to comment out the smooth function just so that my computer runs faster. You can use it on yours. And comments in processing, very easy, just 2 slashes. Makes comments that line. So what I want to do before I draw my line is sort of erase everything that's been drawn already. And I can do that by drawing a rectangle over my whole canvas. So I'm going to say rect for rectangle. And to cover the entire canvas, I'm going to go from the origin, our 0, 0 point, top left, to the bottom right, which is my width and my height. Now, if I run that, it might not do what I want it to do because I haven't given anywhere in here a fill color. So I'm also going to say that I want a fill color, and I can do that in my setup. So I only have to do it once for right now. So I say fill, and we'll make it the same orange as the background. Try that. And here we go. Again, little bit of lag for me, should be running much smoother for you. And it's just a single line following my mouse because every time it goes through this loop, it's drawing an orange rectangle over everything, and then the line. Rectangle, line, rectangle, line. Now, one neat thing I can try is putting in, I can put some transparency on this fill, so it'll leave a little ghosting as I move around. And I can do that by just adding a 4th value, which is my transparency alpha channel. And you can see that line sort of fading away rather quickly, but fading nonetheless as I move the mouse around. And that's because it's stacking the orange rectangles over the processing drawing. Now, to show you an example, I'm going to take that out for now, of how you can immediately make something very unintuitive for the user. I'm just going to switch my mouse X and Y coordinates. So it's no longer going to be drawing to the mouse. It's going to be drawing to like the opposite of the mouse. And it's going to be very jarring. And it's going to take people a while to figure out how this is actually working. Right? And so like my line can go off the bottom because the X is greater than the Y. And it's just very hard to tell where this is going to go. So, usability. Maybe I don't want to draw a line. Maybe I want to draw a ellipse or a rectangle or something else where the mouse is. I'm going to comment out this line for now and put in an ellipse. And for the ellipse, I'm going to have the ellipse start at the mouse. Oops. That's actually a good demonstration, right? So you'll notice it's got some color formatting. Certain things automatically turn into colors, like the functions it knows turn blue. Some static variables turn pink. And so my mouse Y didn't turn pink because it doesn't know what mouse Y is with a capital M. It'll give me an error if I try to run this. So capitalization matters. And then I'm going to give a lower corner for the ellipse. We'll make it, how about 30, 30. Or I should say a width and a height for the ellipse. Now, problem is, as I draw this, it's going to give me an ellipse with a stroke that's white, but a fill that's the same as my background. Let's take a look. So you can see I've got a circle, really. Now, if I want this to be a solid color, I have to give it a fill, right? So I'm going to go back and put a fill above the ellipse because I want the fill to be set before the ellipse is drawn. So I'm going to set fill. Maybe we'll make this a kind of bluish green. Now the problem is, though, that the first time this runs through, my fill is orange. It's going to draw an orange rectangle. It's going to change the fill to be the blue-green. It's going to draw the ellipse. Then it's going to go back, draw the rectangle, but the rectangle is going to be the same blue-green color because I haven't changed the fill back to orange. Because remember, this stuff in the setup only happens once. And if I set the fill to a new color, later on, it overrides the previous fill command. So I also want to set the fill back to orange before I draw the rectangle. And you might say this fill is now redundant, and I would agree. Take that out. And here we go. Bluish green circle following around the mouse. Great. And background stays orange. Now if I wanted to draw like a series of circles, right? I want to go back to having the background not refresh every time, right? So if I take out my large rectangle and just leave the ellipse, it should give me a trail of ellipses behind the mouse. So the background is still orange because I've got the background still set in my setup. And now it's just going to keep drawing ellipses as I move my mouse around the canvas. So it's almost like the paintbrush tool, except I've got that kind of weird stroke thing still happening. So I can take that off. this point, so get rid of the stroke. And I want to do something else. I want to only draw ellipses if the mouse is pressed, right? Otherwise, I want to be able to move the mouse around, so like I could be able to draw things without continuous line of circles between everything. So to do that, I need to use a conditional, also known as an if statement. So just say if. And to check if the mouse is pressed, again, high level, I can use the mouse pressed variable. And I can think, is this equal to, I happen to know mouse pressed is going to be either true or false. So is it true? If the mouse pressed is true, I'm going to do something. Notice I'm using this double equal sign. That's how I check if something is equal to. If I just used the equal sign, I'd be trying to set mouse pressed to the value true. And we'll look at that further in a minute. I also need curly braces on my if statement. So if mouse pressed is true, then I want to do these things. So I'm going to get rid of them and put them inside my if statement. If it's not true, if the mouse is not pressed, it's not going to do anything. It's just going to skip this. So let's see that. And you'll notice right away we don't have the circle starting in the corner here. It's not drawing anything when I move my mouse in because the mouse is not pressed. So if I press the mouse, I get the circle. And I've noticed something else. Even though I took off my stroke, I'm still getting the default stroke, which is black. So now I'm clicking and dragging, trying to click and drag the rest of my mouse here. There we go. On my smiley face. Okay. If I really want there to be no stroke, I have to literally say no stroke. So that will remove the stroke completely. So we're getting there. Now I might want to also do something where I can clear the screen. If I'm drawing, I want to clear the screen to start a new drawing. And so maybe like if I press the C key for clear, I could do that. So I need another if statement. And I'm going to say if key pressed equals true. Now, I'm going to use a shortcut here. I could say if key pressed equals true. But with these Boolean, we call them Booleans if they can only be true or false, key pressed, mouse pressed. I don't need to actually put the equals true in there. I can just say if key pressed. And processing knows that if I just say if key pressed, I'm looking for it to be true. So if key pressed is true. It's an abbreviated form of that. So if key pressed, I want it to do sign. But I need to check which key, because this is just going to tell me if any key on the keyboard is pressed. So I need another if. So I need an if within an if. If the key pressed, and if the key equals C. So I'm using quotes for my character. And I might have to check that. I'm not sure I've got the formatting on that right. But I'm going to see. So now is where I want to draw my rectangle again. So if I want to clear the screen, I'm going to draw a rectangle over everything. So I'll copy these back, put them in that if, make sure this is not commented out. And now I need to close both of these ifs with curly braces. Processing is great. It shows me, by sort of drawing an outline around the curly brace, that this one is paired with. So I know I still need another one for up there. If I click down here, it's going to highlight the one at the beginning of the draw function. All right, let's see that. Okay, so I've got my blank canvas. I click to draw some green circles that do not have strokes anymore, which is great. And I'm going to press the C key, and it does clear with a new rectangle. I can start a new drawing. So exciting. Okay, try it again. Clear. There we go. Now, what if I want to save my image, right? I could save what I drew to a JPEG file. That would be cool. So maybe if I hit the P key for print, I could save an image. So in my larger if of key pressed, I'm going to put a second sub-if, and this time it's going to be if key really equals P, do something. Now, off the top of my head, I can't remember how to save the screen, right? So I'm going to look at the processing reference. There's a couple ways I can get there. On the processing.org website, I can go to reference. But also, the reference is included with the program, so you don't have to be online to use the reference. I can right-click on any term, function, command in processing, and if it's in the reference, it's going to give me this find in reference link at the bottom, and I can click that, and it will pull up the file version of the reference and tell me about that command. So it's going to tell me about key pressed. It's going to let me know some details about that, and it's going to give me a little example code. Boolean system variable, key pressed. True if any key is pressed, false if no keys are pressed. And then it's going to show me like related things that might be helpful, like knowing that to tell what key is being pressed is the key variable, system variable. Okay, so I want to look in the reference for how to save an image. So look for image. I think it's save frame that I want. Yeah, save frame. So if I hit the P key, it's going to save the frame of the animation. So remember, we're kind of doing an animation here when we write this code, and it's thinking of the frames as each time it runs through the draw function, it's making a new frame for the animation that we see in the canvas. And that's going to become relevant when we look at this save frame function, because we can just call save frame and it will give us default text of screen-001.tiff. But we can give it some parameters. So we might want to call it something specific. We call it line. We can give it a number of hashtags. Will give us how many digits it's going to put in the file name, and then we could change the file type. So we could say PNG. And so this is going to save an image, and the number there is going to be the frame number of the animation, which is also a reference to how many times it's looped through the draw function. So if the key is pressed, I'm going to save frame. I'm going to call it test. We'll give it 3 of those. Oh, and we'll do PNG. And one other thing I need to do before it can save an image, I need to save my sketch. So I probably should be saving my sketch frequently as I do this. Okay, so I've saved my project as demo dig 2500, and we're going to see if we can print or save some of these frames, and they're going to be saved into the folder. So when you save a processing sketch, it puts it in its own folder where you can have the code file, the files it saves, other assets you want to bring in to your program. So let's run this. And I'm going to do some circles. And save those frames by pressing the P key. And let's see if it worked. So close that. Go to my Finder. And it's given me a whole bunch of those drawings. Almost so many that I ran out of hashtags for my number. We can see the naming convention on what it looks like. And why did it give me so many? Well, remember that it's going, if I'm holding down that P key, it's going to save a frame every time it loops through, and notice that that P key is pressed, right? So if I hold it down for even a second, it's going to save multiple images. So I can mitigate some of that with a temporary variable to tell me whether or not it's saved an image since the last time I saved one. So first, let me delete several hundred of these. So to check that, I need a temporary variable where I can store this key pressed information. So what am I going to do? To make a global variable, I'm going to declare it above my setup. I'm going to say Boolean. We'll call it saved. And I'm going to initially set it equal to false because I haven't saved anything yet. So I've got a variable called saved. It's of type Boolean, and it is initiated with the false value. So now I can access that variable in my setup function, in my draw function. If I declared the variable in my draw function, I could only use it in draw, and if I set it to something like it would get reset to false every time it looped through, which may not be what I want, particularly if I'm storing like something to check if it's happened or not, like an event state. So we can get rid of that. So down here, I need a further if in my key press. So if the key is pressed, and if saved is false. I want it to run the save frame function. But I can combine these if statements, right? So let me get rid of that. And I can say if key equals p and two and signs, saved is false. Then it's going to save the frame. If not, it's not going to do anything. But once it saves the frame, I want saved to equal true. So I press the key P, saved is false because I initiated it as false. It saves the frame, save becomes true. Draw function happens again. Even if I'm still holding the P key, key is pressed, but saved is now true. It's not false, so it's not going to do this. But if I ever want to save an image again, I need somewhere to set saved to false. And the best place to do that would be in this if key pressed if. So after that one has run, so I want to do something instead. So if the key is pressed, it's going to check these. If a key is not pressed, that means the key's been released. Then it's safe to set saved back to false. So at the bottom of the key pressed if, and again I'm checking my brackets here so I know I'm at the right one, I'm going to say else. So if the key is pressed, it's going to do that. Otherwise, it's going to do this stuff, and that is to set saved to false. And again, notice the difference in the equal signs. 1 equals, I'm setting the value of saved to be false. 2 equals, I'm checking to see if it is false. And I need a curly brace on the other end of that else. And so that should limit me to one image, no matter how long I hold the P key. Let's try. Okay. Draw some circles. Great. Now I'm going to press and hold the P key. And you can see in my Finder window that image file popped up. I'm still holding the P key. I'm going to let it go. And I can see I've only got one image. Great. Hit frame 692. If I go back to my drawing, I could clear it with the C key still. Make a new drawing. And print that one, P key. New file, still holding P key, let go. Great. So that works. Now, let's say I wanted to debug that situation, right? I want to test to make sure it's doing these things like just once, even though I just did. I can do that in code too. So, for instance, let's say I wanted to see if the key was being cleared. I can print stuff to my debugger pane down here by just doing print line. And I could type in variables here, like I could check what key is being pressed. Or I could say text if I use quotes. So I could say window cleared. Except I need to close my quotes. There we go. If I wanted to see like what that key pressed was receiving, right, in the key pressed if, I could do print line key. Now, if I can also use print, which will put the things on the same line here. So I could do print key, print window cleared. They'd all be on the same line, and that line will just keep going forever. So I like to use print line with the ln, and that way it'll put each call to a new line. So we can run that. And for instance, if I press the W key, I don't have W set to anything, but it should give me a W's, or a stream of W's down here. So again, it's going to print a W every time it loops through draw. And then if I do the clear key, I should get that window cleared. There we go. And it's giving me the C key, right? Each on new lines. So that's a super useful and helpful way to debug your code, to see if, like, is it even getting into this if statement? Sometimes that'll happen. Is it even knowing that I'm in the mouse pressed if, right? I can use some print lines there to see right away if it's even getting to that chunk of code. All right, so it might be helpful to put a little bit of text on our canvas that explains that these key commands exist, because as it is, if we're running our application, there's nothing really to indicate that we can clear the screen or save it at all. Yeah. So a user might not really know how to interact with this. We can add text fairly simply to the screen just by using the text function, and we can type a string of text in here between quotes, or we could pass it a string variable. So I'm just going to say C equals clear and P equals save frame. And then we give it an XY coordinate for the bottom left corner of the text. So I'm going to put this in the very bottom corner of the little screen there, so it's going to be 0 for X and height for Y. We can try that. And there we go. Very close to the bottom. I might want to move that up a little bit, but we've got our commands there. So to move it up, maybe I'll say -10, because remember the Y increases as we go down. Okay, so we've got the drawing application. Another thing, now that our code's getting a bit complicated here, a bit long, is I might be good to go through and comment out some things so that we know what's going on. So I could say above our text thing, in a comment, print instructions to screen. And then above mouse pressed, maybe I'll say drawing feature. And then in the key pressed area, I could say clear screen and save image. And this is just helpful to do so that not only you know what the different parts of the code are. But if you share this with someone else, or if you're working collaboratively on something, it's super important to have comments so that it's very clear to someone reading this what's going on without having to look line by line, variable by variable to figure out how your code works. It's also very helpful to you if you write a program, some code for something, and you have to work on something else, you put it away for a couple months, you come back to it, and you think you're going to remember what all this does, but in a few months you come back and look at this, and it's not going to make any sense to you without comments, and you're going to have to sort of relearn what you actually wrote in the code. So putting comments, descriptive comments in, is a very good practice. Okay, so we still need to get this to actually draw our Donald Trump head images, not just ellipses. So we can incorporate image files into processing fairly easily. But there's a few steps that we need to do to do that. And the first is to declare our image variables. These are actually a class. P image is processing image class, and it's kind of like a data type, like our booleans, integers, floats are floating point decimal numbers, characters like the C with the single quotes is a character. We want to have an image though. So maybe I'll call it Trump1. And so what I'm doing now up here in our global variables area is I'm just telling processing that I want a container, really, a space in memory to hold an image, and I'm calling that space Trump1. In my setup, I'm actually going to load an image into that space. This is like where we have saying Boolean saved is making the space called saved in memory for a Boolean variable, and then we're setting equal to false. I can't do that with a image. It's a bit more complicated. So in the setup, I have to load those images. So I'm going to say Trump1, that's my image space, except I'm not going to use equals. Yeah, I'm say equals load image, and then the name of my image, which I believe is Trump1.png, and quotes. Okay, so that's going to load this regular image file into this variable space. Now, an important step that I can't forget is I have to let processing know where those files are, and processing wants them to be in a very particular space, in a data folder within the sketch. The easiest way to get stuff there is to go up to my sketch menu and go to Add File. And that's going to bring up a dialog. I can navigate to my images, and I can import my images into the sketch. Okay, so I've already added Trump1, so I just added Trump2. And just to show you, these are regular image files. So here we go, looking at my processing sketch folder. Oops. So here I've got all my processing sketches. I'm in the demo Dig2 2500 folder. Here's my sketch, And so it adds this data folder that has my images. And you can put images in here, you can put Excel, CSV, spreadsheets, any kind of other files that you want to incorporate in your sketch go into this data folder. And looking at these are just very small 100 pixel by 100 pixel PNG files. The important thing is, though, that I've gone in with Photoshop and made the background transparent, because that will help the effect that we want to do in the painting sketch. Okay, so I've got some images. I've got the variable space for them. I've got them loaded in here, and so then I have to draw them. So instead of drawing an ellipse, I want to draw this image. And to do that, I say image. Very straightforward. And I give it the P image that I declared at the top. And an XY coordinate. Mouse X, mouse Y. Now again, this is going to give me a corner of the image, and I'd like it to draw on the center of the mouse, not from a corner. And since I know that they're 100 pixel wide images, I'm just going to say -50 on both the X and the Y, and that will give me the center of the image. Okay, let's try that. Oops. So, this is good. It's showing me I've got a syntax error, and it's going to suggest what it thinks it is. Maybe I'm missing a semicolon, and then it's going to highlight the area where it's encountering the error, and it's going to highlight right after the error. So if I look at the line above, my Trump equals load image, yep, I am indeed missing a semicolon up there. And we'll try running this again. Aha, and it's giving me another syntax error. Function load image string does not exist. Well, that's super weird. I thought that was it. I could go check my reference, right, which I've got open over here, and indeed, capitalization, just like in HTML, really matters in processing. Load image has a capital I. Now it turns blue, and I should be good to go. So here we go. We will try to draw with Trump. Wonderful. And it's not quite what I thought, and I can notice right away I put mouse Y -5, not -50. So I'll change that. And the other thing you may have noticed is that text went from white to green, right? Why did that happen? So white is the default fill color. And so when I first wrote that text, it had a fill of white, but then that fill got changed as soon as I clicked the mouse to green, and it never got changed back to white, so the text turned green. You can do a lot with the text, changing it, the font, the size, color, all that stuff. For more information on that, just look in the reference for text. And remember, you can get to the reference by, not by highlighting everything, by right-clicking on a command or function. Okay. The last step is that I'd really like to be able to change which Trump head I'm using, right? Because I've got a couple of them. So let me go ahead and add the rest of those. I've got 1 and 2, I need 3. Alright, so I really want to have more than one Trump image, so I'm going to make an array of images. I can make an array of any data type, so to make my array of images, I'm going to say P images and then brackets, open and close, equals, or I'm sorry, it's going to be an array of images, but it is of type P image. Brackets equals new P image. This is a bit redundant. Array, and I have 5 images, so I want this array to have 5 spaces in it. Okay, so that's giving me an array. I still need to give it a name, though, so I'm going to call it Trumps. So I've got an array now called Trumps with 5 slots, and each slot is going to be a P image. An array is kind of like a list of values that we can access conveniently using one name and then a number, to like the slot number for each item in the list. Now I need to load all my images into the array. I do that in the setup. So I'm going to say for. So for is a loop. We're going to make a loop that was going to loop a certain number of times. It's like a mini version of our draw. And I need to give it 3 parameters. I need to know what it's going to use to count through the loops, how many times it's going to run the loop, and then how it's going to increment the counter so it knows where it's at in the loop. And for whatever reason, we traditionally use the integer I as the counter. So I say int I equals 0, and we usually start the loop at 0. And we separate these attributes with semicolons. So integer I is equal to 0, and that's our counter. We want to loop for each item in the array, so 5 times. So I could say, well, I is less than 5, but if I change the array and add more images to it later, this isn't going to work. I'll have to change both these numbers, and I don't want to have to do that. So instead, I can directly access the length of the array. This is like using width and height instead of the size values. And to do that, I can say trumps dot length. And that's going to give me the number 5, because that's how long the array is. So why am I saying less than 5? Like, don't I want it to include 5? Well, we're starting at 0, so we're going to go through 0, 1, 2, 3, 4, which is 5 times. Another semicolon. Hey. There we go. And then I need to increment I each time I go through the loop. I can also de-increment. I can count up, I could count down. And the easiest way for what we want to do is to just say I plus plus. And so what plus plus means is take the value of I and add 1 to it. So we go through the loop. Once I is 0, go through, come back. At the end of the loop, we take 0 equals 0 plus 1, so I equals 1. And we go through, I equals 2, I equals 3, I equals 4. And when I equals 4, it will come down, finish the loop, plus plus, I equals 5. It gets into the start of the loop again, but 5 is not less than trumps.length. It's equal to trumps.length, so then it won't run the loop. It'll just skip it. Another way we could write this is I equals I plus 1. And if we wanted to increment we could count by 2's, right? If we wanted to go 0, 2, 4, 6, 8, we could do that. I'm going to leave it as plus plus. We don't need a semicolon after the last one. We just end our parentheses, and we do our curly braces. Again, kind of like an if. And I'm going to go ahead and close those curly braces. So for this, here we need to load images into our array. So I'm going to say trumps, which is the name of our array, and I have to give it a number, like which slot in the array do I want to load. And conveniently, I can give it a variable. So I can say trumps I, for instance. So when I is equal to 0, it's going to give me slot 0 in the array. And you might be like, what do you mean slot 0? So with computer programming, we often start things with 0 instead of 1. So 0 is actually the first slot in the array, and 1 is the second slot. Slot 4 is the fifth and last slot in this array that we're working with. So we're going to say trumps I equals load image. And this is where we can get clever with our file names. You'll remember I had those files, trumps1.png, trump2, trump3.png. So I can say I can form a string dynamically here too. So I can say trump in quotes, and I can say plus I. So it's going to add the value of I to the string, not mathematically, but like as text. And then I want to add more text to that, so I'm going to say plus dot .png for the file type. Okay, so that's going to load our images. Now, when we draw an image, we want to say we need to call one of the images from the array now. We can't just say trump1. We're going to say trumps1, which will actually be the second image in the array. So let's try that. And I think it's actually going to give us an error. Yeah, there we go. The file trump0.png is missing or inaccessible. Make sure the URL is valid or that the file has been added to your sketch is readable. And thinking about it, I remember I did not have trumps0. Remember, because the first time it goes through this loop, it's looking for trump0. So I can change that. If I go back to my Finder in my data folder, so these are my images, and this trump5 I'm never going to get to because I'm never going to have trump plus 5. So I'm just going to make this one trump0. Okay, and click and draw. There we go. What else? Okay, final things. I'm going to take out the green fill. It's no longer necessary. I think I'll change the background back to white here. And so I want to make it able to change the image, not just static, not just always one. So I need a counter, another kind of counter variable, and one that's going to be globally accessible. So I'm going to make a new integer. I say int. We'll call it current Trump, and it'll begin at 0. So we'll set it equal to 0. And then here, instead of saying 1 or I in my image, I'm just going to have it draw the current Trump. So when sketch first begins, that'll be Trump 0 image. Now in key press, let's say if I press the T key, it'll change that image. So down here, we'll add a change image comment, and if key really equals T, and we'll just cycle through. So we'll say current Trump plus plus. But I can't just do that indefinitely, right? Because if I keep hitting T more than 4 times, I'll get to Trump 5 and 6, which don't exist in the array, and it will give me errors, which I don't want. So within this if, I need another if, which says if current Trump is greater than or equal to 5, I could be even more clever, right? I could say Trump's dot length then I just want to send current Trump back to 0. Close that if, close the first if. Should be good. Last thing to add is to our text here, we can add T equals change Trump. All right. And I just might want to make this a little bit bigger now, so I have a bit more space to work with. So I can make the size 600 by 400. Go ahead and save. And we'll run that. Let's see, last thing. Since I've got a white background now, the white text isn't going to do it for me. So before I draw the text, let's make the fill nice dark gray. Okay. And since we made this bigger, it's going to really challenge my computer doing the voice recording here, so I'm going to run it separately from this. Alright, so hopefully using this smaller screen will let me show you the final results here in a faster manner. And so we can click and draw with our trumps. If we press T, we can change the trump. Going through all of them. And then we should be back at our first one. And so there you go. that is your demo and introduction to the processing programming language. There is so much more you can do with this, but I think this will be a good introduction to the key features of not only processing, but writing computer code and doing computer programming in general.